Welcome everybody, this is Moballer12. For this video I'll be discussing and going over the Newman projections of molecules such as ethane and butane. So the way I've divided this series of videos will be, for the first part I'll discuss the Newman projection for ethane, and in the second part I'll discuss the Newman projection for butane. So let's get started with our discussion on ethane first. Okay. First things first, I want to discuss a few key words. The first one is Newman projection and what that is. Okay. Some professors or teachers define the Newman projection as looking at a molecule from a bird's point of view. The way I like to define the Newman projection is looking at the carbon backbone of a molecule. So for example, if this is your ethane molecule, and here's your 6 H's drawn as such. What I mean by looking at the carbon backbone is by looking directly straight at it like this way, okay? From right to left or from left to right. So for example, if your eye is over here, you're looking directly at the carbon backbone. It's a linear line. You're looking at it straight on, okay? So for example, here is the ethane molecule, and I'm using a model kit. So there's your 2 carbons and your 6 hydrogens. The white ones are the white balls are the hydrogen atoms. So if you look head on the carbon backbone, for example, assuming that the lens of this camcorder is the eye, it will look something like this. Okay, we're looking head on. Okay, so that is what a Newman projection is, looking at the carbon backbone head on. Okay, so if you're looking at it from right to left for ethane, okay, this carbon, you look at this carbon, you'll see this carbon first and you'll see this carbon second. So first and second. That should make sense. Okay, so let's draw the Newman projection for it. So there's 2 conformations for ethane. There's one called the staggered conformation and the eclipsed conformation, and I'll go through the attributes of each conformation. So let's just get a feel for just what the Newman projection looks like. The first thing is first. So again, if this is your ethane molecule, the way you want to, and again, this is carbon number 1 and 2, assuming that you're looking at it from right to left. Okay, the Newman projection is drawn as such. Your first carbon, basically the carbon number 1, the carbon that you're looking at first, will be drawn as a dot. Okay, and then the second carbon will be a large circle. Okay, so there's carbon number 1 and carbon number 2. This is the first carbon you see, and this is the second carbon you see. Okay, so let's draw in the H's now, the hydrogen atoms. So there's one hydrogen there, there's another hydrogen there, there's another hydrogen atom there. Okay, so we've drawn 3 hydrogen atoms attached to carbon number 1, and let's draw the rest of the hydrogen atoms. There's another one there, there is another one there, and there's another one here. Okay, so we've drawn all 6 hydrogen atoms, and basically this is what a Newman projection is. Okay, this specific projection I've drawn here is called the eclipse conformation for ethane. Okay, this is eclipsed. Okay, think of an eclipse as you would think of when the moon passes through the sun and earth, and it partially blocks out the sun, or fully blocks out the sun, and then you get partial or total darkness. So that's the same way you want to think of it. Okay, so this is eclipse, and as you can tell, the hydrogen atoms are directly eclipsing the hydrogen atoms in the back. So the hydrogen atoms to connect to carbon number 1 are eclipsing the hydrogens attached to carbon number 2. Let's look at the model kit briefly. As you can see, this is the eclipse conformation. they're directly on top of one another. They're blocking each other out, okay? So that's the eclipse conformation. The hydrogen atoms or whatever other atom directly on top of each other, okay? So this is the eclipse conformation, and this is not really stable, okay? Not stable. And I'll go over that reason why. So it's not stable, and the main reason why it's not stable is because of torsional strain, okay? Torsional strain, okay? So what is torsional strain? When you have atoms eclipsing like the way they are here, the hydrogen atoms are eclipsing the other hydrogen atoms in the back, what will happen is the bonds, these bonds are directly above one another, okay? And so as a result, these again these bonds are made up of electrons, right? So when they're right up on top of each other, like charges like to repel each other, right? So when you're forcing them to be in this eclipse position, you're building up a potential energy, this type of energy, this strain, and that is what torsional strain is. It is basically the one bond eclipsing another bond. So you're forcing the electrons to be in a position that they're not really comfortable being in. If they have the choice, this molecule would rotate 60 degrees like such to be in the next conformation that I'll be discussing, and that is the staggered conformation, okay? So again, if we rotate it from the eclipse conformation 60 degrees as such, this is called the staggered conformation, which is much more stable. It avoids torsional strain. Again, torsional strain is when you have a bond directly above another bond and the electrons are interacting with each other. So let's draw the next conformation, and that is staggered. So again, this pen is dying on me. Okay. Staggered conformations where you have the hydrogen atoms in the back spaced out. So starting from the eclipse position, what I had shown you guys earlier, if you rotate this 60 degrees, now now you have it in the staggered position, and that is much more stable. So this is staggered. Okay, staggered and much more stable. This is stable, okay, and let's see, hold on one second. This is staggered and this is much more stable, and so that concludes the Newman projections for ethane. So like I said again, there are two Newman projections. There's one which is the staggered conformation, which is very stable, and there's one, the eclipse conformation, which is not so stable as a result of torsional strain. That is, the bonds, when they're eclipsing the bonds, the electrons are interacting with each other, and you're forcing them to stay in a position that is highly unstable, and they want to rotate 60 degrees to get to the staggered conformation. Okay, so that does it for ethane. Again, just keep in mind, two conformations, one staggered and one eclipse. Staggered is stable, eclipse is not stable. Why is it not stable? Torsional strain. And there you have it. So stay tuned for the next video, which I'll be discussing the Newman projections for butane.